Greeting, Professor. My name is Mui Hiang, and I will be presenting Project 2 of CSCI 331 operating system. So in this project, we will be looking into the producer and consumer interaction. There will be two files. So the first file will be the race problem, and the second file will be the solution to the race problem. So let's get into the race problem file. So here in our race problem file, we have all the necessary variables, the size, next in, next out, and our round to keep records. So let's look into our producer function. So our producer function, here there will be a random generated length for K1. So it's from 0 to 33. This varies from different buffer size because my buffer size is 100, that's why it's 33. So let's look into our for loop. After we attain our length, basically we're just writing the amount of length we have from 0 to that generated length, initializing all the value to 1. And next in is just basically finding the next position for our producers. Let's look into our consumer. Oh, not to mention that here I'm basically just sleeping the producer function in a random range from 0 to 999 millisecond. Yes. So let's look into our consumer. So here we basically the same thing, just randomly sleeps the consumer function. And here we're just generating a random length as well, basically 0 to 33 as well. And for our for loop, from 0 to that specific length, we're just checking the data in that position. So we're obtaining data and then check the condition whether it meets any of the following condition. So the first condition, if it's above 1. So basically this condition means that the producer is basically overriding some of the buffer space. Okay, and the next condition is if the data is equal to 0. So basically that means the consumer is over-consuming and the producer is producing too slow. And if none of the condition is met, we're just gonna continue our program and just initialize that position back to the value of 0. And next out is just basically the next position for our consumer. So here we're just creating a threads and calling the threads. So let's look at our result of this file. Okay, producer is too slow. Okay, let's see if we can get consumer. Okay, no race. Okay, still producer still slow. Okay. I don't know if I can get the consumer. Oh, okay. Okay, here, the consumer is too slow. So now let's move on to our race problem modified. So this is our solution. So basically we're just using semaphore. So here's our semaphore class, our required integers, variables, excuse me, and our constructor and the necessary operation P and V, basically just for weight and signal. So let's look into, so basically this is just the same necessary variables, except we have 3 more new variables for the semaphore. And let's see if there's anything different in our producer function. So we can see that after we generated a random length, we call empty.p. So basically this is just to decrease the buffer size in basic, how would I say it? So the empty is initialized to the buffer size. So we're just decreasing the amount that we had generated from the K1 length. So here we just, this is just a condition to check whether the producer can write or not. Here is basically the same thing. We get a green light and we can just write same code, next in the same parts. So here we just increasing it back to 1 so that the next threads can operate. And for our vfull, so here we're just increasing our full to the length we have generated, K1. So we randomly sleep the program. For a specific length, let's look at our consumer, the wheel source. So this is the same part. So here, basically, we're just decreasing instead of increasing because the consumer is consuming. that specific K2 we generated. So this is the same thing, works like a producer. And this is the same condition. We are checking whether if the data is above 1 or equal to 0. So if it's not, then we just initialize 0 to that position value. Basically, next out is just taking the next position, and then this is just increasing for the next operation. And here we are decreasing. Oh, we're increasing. Apologies. We're increasing the empty values back because we consume this like the length, specific length already. So let's see our result for this. Might take a little long. We can see there's a lot of successful message. This is what we want to see. And hopefully we reach the end with a message that say no race has arisen. Yep. Okay, program. Program complete successfully after 50 rounds with 0 race conditions. So that is the end of my presentation. Thank you for listening.